Thank you for taking the time to join me today. Today, I'll be discussing match effectors, or MEF for short. And I guess a little bit about myself is my name is Alan Zhao. I'm a current rising junior at Cornell University. At Cornell University, I am a computer science major in the College of Engineering. Within computer science, I plan to have a focus on artificial intelligence. And I'm also doing a business minor to go along with that. And I guess my big extracurricular is I also play on the varsity football team at Cornell. So with that being said, I will get the presentation started. So yeah, just first off, what is an MEF? Match effector is a battle management decision process that selects and recommends the most suitable military assets, which are also called effectors, to achieve a given effect: destroy, disrupt, survey. And so essentially, I guess within the military, you have these people that are battle managers or battle commanders. And the way you can think of that is they are essentially people that are air traffic control, but for the military. So regular air traffic control, they're trying to direct airplanes to this airport, to this area, and they're trying to avoid airplanes or avoid airplanes from colliding with other airplanes. Now, essentially, these battle commanders do the same role for the military, only instead of sort of, I guess, making sure planes avoid each other, they actually direct, I guess, friendly resources to go engage or I guess, find out mystery enemy uh, sort of engagements. So essentially, to reach a decision on send which airplane or which tank to deal with this enemy sort of vehicle, a battle commander has to essentially do a match effector on his own or on their own, and sort of calculate the information just sort of in their head and all the probabilities of what tools are best for which situations. So that's what a match effector is. And so I guess the opportunity we got was to build a match effector in a sprint. And so that sprint was Dash 2 MEF, which was hosted by the Air Force. And so just a little bit more on this amazing opportunity with Air Force it was 2 weeks long in Las Vegas, Nevada. And I guess what DASH stands for is Decision Advantage Sprint for Human Machine Teaming. So essentially, the Air Force wanted access to these different companies with amazing knowledge and amazing technologies, and sort of find ways to make humans' jobs easier and more efficient. And so that was how, I guess, Decision Advantage Sprint for Human Machine Teaming came about. And so it's Dash 2 because this was actually the second sprint. The first sprint was shorter. It was 1 week for a perceived actionable entity, which is sort of another type of microservice within the Air Force. But we were working on Dash 2 MEF, which again was 2 weeks long. And so just anyone in government that was involved, include the US, German, and French Air Forces. So all three of those Air Forces were there for the entire 2 weeks, just sort of witnessing and learning how technology is built and sort of what our technologies can do. I know the U.S. Space Force and other government officials also joined us the final 2 days for the final product demos. And so after we simulated our project or used our product for simulation, we were able to attend a brief and sort of answer any questions that any of these government agencies had about our technology and sort of our way of thinking. And so just other industry partners that also attended Dash 2 MEF, Leidos, Anduril, Omni Federal, Rachner, and STR were all there. So we were in really, really good company. And overall, the 2 weeks were extremely challenging, but also extremely fruitful for both the Air Force and ANO. So with that being said, I'll go into more about what we actually did during this 2 week sprint. So essentially, the main thing we had to solve was how we were going to build this MEF, this match effector, that was going to provide useful sort of recommendations to a battle manager during a battle. And so the challenge with this was no MEF had ever been built. Any sort of microservice, it didn't exist. Nothing that had already been built was anything like this. So we had to build a microservice that was completely new. Coming into it, the Air Force people were telling me, literally 2 weeks ago, we had nothing to do sort of this sort of action, this microservice. So that was our challenge. Was we didn't really have anything to go off of. We had to sort of brainstorm and come up with it completely on our own. So I guess breaking down our challenge into actually building this microservice was three main parts: data, algorithm, and display. So data, there's different data we could use from the battlefield, and implement it into our algorithm. So we had to decide sort of what data we wanted to use and how we were going to input it into our algorithm. So different data examples we had access to were IRC chats, which are essentially just when the battle commanders are in the middle of their battles, they can sort of type in a chat and communicate with each other that way, almost like a video game. They also have STT streams, which are speech to text streams. So just like the chat within the battle command, these battle commanders, these battle managers could also sort of talk to each other through audio. So we had access to speech to text streams, and then we also had telnet data. So the telnet data was specifically straight from the simulation, and it had information on sort of all the different vehicles and entities in a battlefield, and also their call signs and their locations and their speed. So similar to also data an air traffic controller would have access to. And so the next step with that was once we figure out how to get the data into our system, how to use data, we had to figure out an algorithm. So we had to develop a logic that could produce quick and accurate results for the battle manager use. And so that step was just figuring out the logic and how we're going to get from point A, which was we have this raw data, to point B, which was display how we're going to communicate our recommendations. And so that sort of leads to the third part of this big challenge, which was displaying our recommendations. How could we effectively communicate our match effectors, our recommendations to the battle commanders so they could not only use our recommendations, but also get details on sort of the reasoning behind why those decisions were made. So that was our big challenge, and those are sort of broken up into three main parts on how we're going to tackle this. So I guess from that challenge and from those three main parts, we sort of developed a pipeline for a match effector in five main steps. So I'll just go through those steps right now. So option one was input, which directly correlates to data I was talking about. So for the input, we had two options for the battle commanders when they actually ran our pipeline and used our match effector. When they hit the run pipeline button, they could either use the last IRC chat, the last I guess chat that was entered in sort of the chat room, or they could enter their own chat prompt. So think of like a ChatGPT type box. From there, with the prompt that we got, whether it was the IRC chat or a manually entered chat prompt, we had to do some data cleaning. And essentially that was to just restructure, reformat the prompt into something that was more readable for our model. And what I realized is when we just inputted the last the raw IRC chat or the raw chat prompt, our model would have extreme difficulties with sort of figuring out what the battle commander wanted and what needed to be done. So a simple data cleaning sort of run helped a lot. And so what that was, it would eliminate typos, any spelling mistakes, and just unnecessary information. For example, the IRC chat, it wouldn't just be, engage enemy aircraft with aircraft. It would have a bunch of random symbols and then a username for the battle commander that entered that message, some more buffer sort of information that was irrelevant, and then finally the prompt that needed. So that step 2 data clean was really important for the success of the rest of our model. And step 3 of categorization, which was really the main bulk part of our pipeline and our core logic. So essentially, we utilized information from the database with all the airplanes that the Air Force had access to, all the Air Force or all the airplanes and vehicles we had access to on a given day, and the sort of different probabilities for each friendly entity with each enemy entity. So literally you had all kinds of different aircraft, friendly aircraft, enemy aircraft, friendly ships, enemy ships, sort of any sort of friendly and enemy sort of entities they had. It was in this database, which included probabilities that stated how effective our friendly entity was on a enemy entity. And one thing I forget to mention for step 2 was before the pipeline, Some data cleaning that we had to do was all the data, all the databases we were given were in Excel sheets. So we had to sort of upload those spreadsheets into our system, and they're usually into JSON files or Python lists. And from there, certain call signs, certain names had to be restructured in the same format. So, example, one call sign might be Harpy in one database, but in another database, it'd be Harpy01. So those are the same call signs, or they were different call signs, but they were referring to the same thing. So we had to sort of structure that into one format. So between that data cleaning and the prompt data cleaning, that really set up our categorization process for success. So the next part, step 4, was actual evaluation. Was basically when we got to our final match effectors and our final recommendations. Essentially, our pipeline, you'll get to see it later, I believe on the next slide, would get to a certain point where it would choose the best weapon or best tool to use for the specified enemy entity. And so the final step for that would be step 4, evaluation, was finding the sort of vehicles that had the capabilities or had the technology that we recommended. And so from that, we had to pull from the local database that could change on any different day or even any different battle. So that was battle specific. And so from that, once we got the evaluation done, we would move to the step 5, our final analysis, which was essentially the UI part of communicating our findings and our recommendations to the battle commander. So yeah, and we also made sure to include detailed information that the battle commanders ended up really enjoying and actually utilized a lot. So next slide, we have the actual categorization process, and you're seeing a little bit of our UI. And so this was at the bottom. This was a reasoning trace. So the battle commanders, when they ran our pipeline and they got a batch effector recommendation, they could see the exact steps and exact decisions that our model chose to make before getting to that decision. And that also sort of, I guess, summarizes step 3, the actual categorization sort of part of our pipeline. So first we have the loaded input, engage the enemy's aircraft using aircraft. And that was actually the cleanup version of the prompt. And so if the prompt didn't need to be cleaned, our model would just use the raw sort of prompt. If it didn't need to be cleaned, it would be cleaned up and then displayed on this sort of reasoning trace, which is what you see of the loaded input. And from there, it would just sort of, I guess, crop out irrelevant categories and choose the best option within that category to sort of reach its final decision. And you can see that here. So PAE wasn't really influenced the rest of our category, but it was nice to have to give the battle commander sort of more background on sort of the action that needed to be taken. So the first sort of categorization was air to air. So it could be air to air, air to surface, surface to air. So it would take our input prompt and sort of categorize that. So that was our first category. And from air to air, it would give us platform type and platform name. And so what platform type was sort of the platform that the enemy was. And so in this case, the aircraft, it was an enemy aircraft, so it'd be airborne actionable. We would need to take an airborne actionable for the enemy. And so that identified platform name was a best platform for friendly to use to sort of target this enemy platform type. So for this situation, a fighter 4th gen would be the best weapon to target an air actionable and engage the enemy aircraft using our aircraft situation. And so within the fighter 4th gen, of all the sort of tools a fighter 4th gen had access to, we figured out that the AIM-120D AMRAAM missile was, I believe that's a missile, was the best to target an enemy aircraft. And then from there, we sort of just matched the live effectors, like I was saying, step 4, with what the certain battle commanders had access to on that certain day. So we ended up matching 3 live effectors or 3 airplanes that had access to the AIM-120D AMRAAM to sort of target the enemy aircraft. And so these are some of the details considered. So when you're looking at that last slide with the categorizations and the cropping, these are some of the details we considered during that pipeline. So for example, communication deliverables, and there was kinetic deliverables and other deliverables. When out with an air-to-air sort of situation, we didn't need a communication deliverables, whereas the kinetic deliverables might have been more relevant for a situation. Um, and another thing that was also super useful was sort of this drop down menu. We had a lot of information to share based on our match effectors, but we didn't want to clutter up the UI and really only wanted to display information the battle commander wanted to see. So that's why we included that drop down menu, which it gave a super clean look. So essentially, if our recommendations were good, the battle commander basically said, "Great, I don't even need to see details. I'm going to send that in." But if he thought our recommendations wasn't as good and he wanted to see why, he could either go through the reasoning trace, which I just showed, or go through these details and say, "Oh, this is why um, this match effector was made." And yeah, just looking at the information, there's pretty much all the information that was about or that could be found on the call sign. So you had availability, um, a possible match available call sign. So Harpy 01, that's part of what I was saying with the sort of, I guess, data cleaning. And so sometimes the battle commander might input Harpy or they might input Harpy 01. So those are two things. You also had nationality, different deliverables you had in different categories, and also the specific platform type like the F-22. So yeah, just some results we got from our simulation. From when you hit the run pipeline button to the time, from the time you hit the run pipeline button, the time it gave you match effectors or recommendations is around 7 seconds. Sometimes it wouldn't be able to match an effector or find an effector that was useful or specifically useful in the situation. It would be on the lower end around 6 seconds. Whereas if it did find a match effector, it would sometimes be on the higher end, closer to 8 seconds. But either way, even if it didn't find the match effectors, the battle commander could go through the reasoning trace and see the different sort of models or sort of the different decisions the models made to get to the final point. And so even if it didn't find sort of an airplane that had the AIM-120D missile, it could go back and go into their own database and search for either a plane that, or find he could himself find a airplane that had the AIM-120D missile, or if truly no planes had the AIM-120D missile, it could go through the database and find similar sort of aircraft with the missile. And so I guess the total decision time from when you ran the pipe or from when you got the sort of task at hand and you hit run pipeline to the time where sort of aircraft or something was dispatched or a decision was made was around 23 seconds. What was interesting about that was the battle commanders told us that that it took about the same time using our match effector to make a decision as if they weren't using our match effector. So our match effector didn't really necessarily speed things up, but also didn't slow the battle commanders down. So that was the sort of the total life cycle from when the sort of task was produced to when the task was, I guess, taken care of. And so that was around 23 seconds. And so from our simulation, we had a total of around 8 to 9 runs of our match effector of just different tasks that came up. And so we had one valid response and around 5 to 8 invalid responses. And so what constitutes a valid response and an invalid response was 3 sort of categories. If the match effector made logical sense, physical sense, and tactical sense. And so all of our match effectors made logical sense. Okay, this airplane has this missile and it can take care of this enemy aircraft or this enemy entity. But sometimes it didn't make physical sense or tactical sense. And so, for example, the tactical sense was, okay, we have this sort of enemy um, enemy truck that we have traveling. It would be overkill to send a fighter jet to take care of that. Excuse me. Whereas something lighter, something more lighter on the resources could take care of that better. So that was physical or tactical sense. And physical sense, we didn't have time to sort of implement the telnet information. So that's why some things wouldn't make physical sense. So maybe this airplane was too far, but it would still get brought up as a recommendation. So just some final next steps of what we would want to do if we had more time to work on this match effector. And I went into this a little bit more. We wanted to leverage more data. So we wanted to incorporate the speech to text data and the telnet data um, to sort of, I guess, give our model more sort of background information. Another thing that kept on coming up was the different variables that we didn't even have access to, even if we did want to incorporate. Those are things such as ammunition levels, fuel levels, maybe even crew fatigue that could go in a part of a battle commander's decision making that we just didn't have access to. So also incorporating those variables, but also having those variables accessible would be nice. Next thing was fine tuning, so we could either do source fine tuning, Q learning fine tuning to sort of optimize our performance on human feedback. And what we were working with was a zero shot model, and we sincerely believe that if we were to make this model into maybe a few shot model or even a multi shot model, that the results would be much better just with the added sort of background information. And so the last thing we did want to add was just human in loop. We want to involve the battle commander throughout the reasoning trace process. So you saw the reasoning trace was it would just sort of the battle commander would just hit the pipeline and then it would spit out that reasoning trace and give you the result. What we wanted to do was we wanted the battle commander to stop the reasoning trace at certain parts and adjust the model's decision making or change the model's decision to sort of help guide it to information or a match effector that might be more useful. And again, that could go hand in hand with fine tuning. So just overall, our pipeline needed greater flexibility with more ways to address the same challenges. And that flexibility really goes back to the human in the loop box or circle. Was we really wanted more options of jumping from step to step of our pipeline or going back in our pipeline to sort of rerun the pipeline from this point with this information. And so those were our next steps. And yeah, that was the presentation on match effectors. I really appreciate you guys taking the time to watch this.